In this video, we will discuss a problem based on ladder friction. Okay, we have this example in front of us. A ladder AB weighing 196 Newton is resting against a rough wall and a rough floor. Calculate the minimum horizontal force required to be applied at C in order to push the ladder towards the wall. Okay, this is your point C. On this, you have to determine this unknown force P, which is required to push the ladder towards the wall. Okay, so first we will draw the free body diagram of this ladder. This is your ladder AB. This is at this point A, you will have one vertical reaction at A, and this will be your reaction developed at B, right? Then at this point C, there is an horizontal load P. There is one vertically downward acting self weight which will act at a distance of 2 meters, right? It will lie at center. This is 2 meters and this is 2 meters. And now we have to determine the direction of motion of this particular ladder, right? How will you determine the direction? They have asked you, they have told you that the ladder is to be pushed towards the wall. It is to be pushed towards the wall, so your frictional force will be acting in this direction. This will be your mu into Ra. Mu A into Ra, they have given you two different coefficients of friction, and if this is moving in this direction, B point will be moving in upward direction, and if B point is moving in upward direction, the frictional force will be acting in downward direction. So this is mu B into Rb. Okay, this is how you have drew the free body diagram of the given ladder. Now, using your conditions of equilibrium, we will determine the unknown force P. You have three conditions of equilibrium here. This is not an entirely concurrent force system. So you have summation of forces in x equals to 0, summation of forces in y equals to 0, and summation of moment about a certain point throughout the beam AB equals to 0. Now let us apply the first condition, summation of forces in x equals to 0, considering forces acting towards right as positive. Here, what are the forces acting towards right? There is only one force which is acting towards right, which is P. Then there are another two horizontal forces, which is mu A, Ra and Rp. Both of them are acting towards left, so we can write it as P equals to Rb plus mu A into Ra. We know the value of mu A is 0.3, so you get P equals to Rb plus 0.3 times of Ra. Okay, this is your equation number 1. You have another condition, which is summation of forces in y equals to 0, considering upward acting forces as positive. We have three forces acting in vertical direction. One is Ra, one is 196 kilonewton, and another is mu b into Rb. We have considered forces acting in upward direction to be positive. Only Ra is acting in upward direction, so we will have positive Ra equals to 196 plus mu b into Rb. So you will have Ra equals to 196 plus the value of mu b is given as 0.2. So this is 0.2 times of Rb. Let this be your equation number 2. We have one last equation with us, which is taking summation of moments. Right? On taking summation of moments, let us consider summation of moments about point A. Right? If I take summation of moments about point A to be 0, considering anti-clockwise moments as positive, how many forces do I have? I will have horizontal RB, I will have mu b into RB का moment, I have 196 का moment, and I have P force का moment. So RB force will be going in anti-clockwise direction, so that will be positive RB. So plus load into what will be the perpendicular distance, it is 4, and this its vertical distance will be cos 50. So it will it will be sin 50. This is right angle triangle, this is adjacent, so adjacent will be 4 cos 50 and opposite will be 4 sin 50. So the perpendicular distance from RB to A will be 4 sin 50. Then next you have mu b into RB, it is going in clockwise direction, so it will be minus mu b we know is 0.2 into RB into perpendicular distances 4 cos 50, so this is 4 cos 50. Then you have a force of 196 kilonewton acting at a distance of 2 meters. So you have, and this will be going in clockwise direction, so minus 196 into 2 cos of 50, this is 2, so uska adjacent will be 2 cos 50, and at last you have a force of P acting at a distance of 1 meter, so this distance will be 1 sin 50, and this is going in clockwise direction, so minus P into 1 sin 50 equals to 0. On reducing this equation, we will get 0.766 P minus 2.546 times of RB plus 251.976 equals to 0. You have one equation in terms of P and RB. On substituting this value of RA in 1, on substituting 2 in 1, we will get P minus 1.06 RB minus 58.8 equals to 0. This is your equation 3 and this is your equation 4. In calculator you can solve both the equations and you will get the value of P as 240.360 newtons and reaction developed at B as 171 newtons. Substitute these equations. While substituting, make sure you are writing the number associated with the unknown and its sign as well. Here the ordinate of RB is minus 2.546 and here it is minus 1.06. So while solving, you need to take care of these few things. The first step is to draw the free body diagram of the figure. Second step is to determine the direction of motion. Third step is to apply the frictional force opposite to the direction of motion. And fourth step is determining unknowns by using conditions of equilibrium. Thank you.